Hi everybody. The final session for today brings us to Wagner Silveira, another Microsoft MVP from Auckland in New Zealand. With all the available messaging service in Azure, it can be confusing to choose the best offering for your scenario. Wagner is going to give us an overview of all the available services and help you decide which one is the best to implement classic messaging patterns. So that is it. Wagner, over to you.
Okay, thanks, Lex. Good morning, everyone. Oh, good afternoon or good night, depending on where you are. So as Lex was saying, my name is Wagner Silveira, and we're going to be talking about messaging patterns with AIS. Right? Just really quick about me. I'm the principal integration architect at TITA here in New Zealand. So that's actually 6:15 a.m. my time. So even though I didn't fly to London, I'm still probably jet lagged. And on the agenda today, what we're going to be talking about is first go a little bit about the messaging and the Azure Integration Services. So how messaging fits on that, right? Then we're going to be looking into the implementing messages patterns with inside AIS and see some examples of that, how we can combine these services to do that implementation. Then we're going to do a quick demo, and yes, there is going to be Twitter involved on that. And finally, we're going to do a summary of some of the takeaways that I would like you guys to take. So first things first, right? Let's talk about messages versus events. It's something that has been already been written down by Kevin, by Dan Tomei, but there is, although we're talking about messaging services inside Azure and inside AIS in special, messages and events has some different kind of formats or properties. And that means that some of the patterns are going to be better applied to some of them and not the others, right? When you're looking at messages, we're thinking about something that is transactional. We're thinking about something that is, for example, that are going to be issue a command or is going to be passing control from system A to system B for the continued along running transactional workflow, right? Because of that, you have some handling expectations. You actually thinking about expecting that message to be processed or be handled in a specific format or a specific way. In most of the cases, the order with how those messages are being processed matters. Especially because again, in a lot of cases, they might relate to each other, right? Events, on the other hand, they are informational, right? So the idea of the event is I have either a fact or a set of data points from a system. And I don't assume how you're going to be handling that. I'm going to, the event is here is something that happened on my system. If that help you to trigger something on your own system or is going to help you to process something, fantastic. Because of that, we can't assume that order matters because we don't know how this message is going to be, this specific message that is the event is going to be processed. And each event is actually individually important, right? That's why it's not necessarily related to each other. You're going to be handling specific events of a type. And so far we talk about messages and events, but what about streams? The idea of streams, as we said with Kevin yesterday, is that is actually a series of events over time, right? When you're working with streams, we're actually looking at something that the collection of events, it's together is going to be more sense to evaluate or to analyze than a specific event by itself. AIS deals with messages and with event grids. This is part of the package of what we call AIS Messaging Services. And for that, we have Azure Service Bus and we have Azure Event Grids. So When you're talking about service bus, it's going to be managing messages. And those messages are going to be deployed either on queues or topics and subscriptions. Right? The one thing important about the Azure Service Bus is the format to how those messages are consumed is actually dictated by the client. The client that is coming, pulling for the message either on the topics or on the subscriptions, and they're going to be consumed at its own pace. And the Azure Service Bus enables at least once delivery. You can have at most once delivery as well, but most of the time we're going to be working with at least once delivery, because then we wanted to guarantee that the message has been processed on the system before you remove that from the queue. Azure Event Grids, on the other hand, is actually a broker of events. It connects publishers and subscribers through topics and subscriptions, right? The different from the Azure Service Bus, after the subscribers indicate where they wanted to receive the events are pushed from the engine instead of the message being pulled from the client. And because of that, it also implement the at most once delivery. What means that once you receive the message, even if you don't fully process that, Azure Event Grids already did his part. And so far we talk about two of the services that creates or that are part of the AIS umbrella, right? And the two that actually deals with messaging. But what about the other services? How those other services fit? We have Azure Logic Apps, and as you all know, Azure Logic Apps is going to support you with service composition, so getting different components, including the AIS clients, to create the workflows, and also put those service or those components in the order that you wanted to do the service orchestration. API management, on the other side, is going to allow you to compose APIs. So you have a service interface that can be reused by both the Logic Apps, but also external and third-party clients. Let's talk now about how we can implement messaging patterns in AIS. So I go through the 4 patterns. We're going to talk about publish subscriber pattern and how that fits into AIS. Going to be talking about the content-based routing, claim check patterns, and the sequential convoy. So starting with the publish subscriber, at the beginning, you have a sender connecting to a message engine and a receiver also connecting to the message engine. So sender send message to this message engine, which is like a queue. The receiver connects to the queue and receive message back, or depending on the case, the message engine send message to the receivers. What happens when a sender needs to send the same message to more than one receiver? You have 2 options here. You can make sure that the source system, that is the sender, have the burden to connect to a whole set of different message queues and send the message, but that would be like not very efficient, right? Instead of that, we have probably our first pattern. If we implement a publish subscriber channel, now one message arriving at the publisher can go to any receiver that subscribes to that message. In this case, what happens is a message on this side, which is sent, is actually duplicated for any number of subscriptions that is available, right? And how we implement that on AIS? That one is the easy one, right? Because on both Azure Service Bus and Event Grids, you have that out of the box. So Azure Service Bus implement that with topics and subscriptions. And in this case, what the engine does behind the scenes is creates a queue for each one of those subscriptions, right? So every subscription becomes a virtual queue or a hidden queue. You don't see that, but the engine deals with that for you. And it also deals with the ability to receive a message. The message that is receiving from the sender is going to be duplicated in each one of the subscriptions that is required. So all of that comes out of the box. And Azure Event Grids also has the concept of top-end subscriptions, right? So event handlers now subscribe for events, and means when you send a message on this particular endpoint, and the engine push the message to the handler. So in this case, there is no queues in place. So again, both of them out of the box, and we're talking about publish subscriber just because that is kind of a base pattern for us to implement other things. For example, to implement the content-based routing. So back of the original picture, what would happen now if I have a message on the publisher, but instead of each one of my subscribers want an exact copy, they are a little bit more picky about it. So subscriber A want messages from that publisher, but only if it matches the color green. And subscriber B also wants message on that from that publisher, but only if it matches subscriber the color blue, right? So in this case, if I receive a message on this side, what I'm doing is now I need to implement something that routes the message to the right subscription. So if a message arrives on the published subscriber, now that I have the ability to route messages, I'm going to be able to send green messages to subscription A, and I'm going to be able to receive blue messages to subscriber B. How that's implemented on AIS? Well, on the case of Service Bus, you have the ability of creating filters inside that subscription, right? And that is going to be how it is actually implemented on both of them. So far, for you to deal with subscription filters, you have to be writing that on the SDK, or you're going to have to be using third-party software like the classic Service Bus Explorer. With the latest updates on the portal experience for Service Bus, now filters can be edited or updated in the portal. If we have time, we're going to take a quick look on how that looks. On Azure Event Grid, you also have the ability to implement subscription filters, and those filters has been able to be edited or updated in the portal from the beginning. Okay, so far, everything that we saw was either out of the box from the tool, or it was there, is capabilities of the tool, and you have to do some configuration, right? So for the next pattern, that's where you're starting to need to involve other components to do something that the engine doesn't support out of the box, which is the case of the claim check pattern, for example. In this case, I have a message that for some reason is not able to be processed by the messaging engine as is, right? And the reasons could be the message is too big to be processed by the message engine, since both Service Bus and Event Grids has a limit of the size of the message that they can receive. Or it could be that actually that message, you don't want it to pass that directly to the other side. You just wanted to signal to the receiver that you have a message and have some other kind of validation from the receivers to pick up that file, right? So how I would be doing that? In this case, I need a secondary repository I need something where I can store that message, and I need something to identify that message to pass it on to the message engine. In this case, what would happen is something like this. I create the message stored on the repository and then create a little key or a unique identifier and push it back to the sender. Now what the sender is going to be doing is passing some metadata, enough metadata for example, fulfill a subscription filter or to identify what this message is about. So the receiver can process that and send it to the receiver. The receiver on the other side also needs something to connect to the data repository and pick up the code to push it back. So we can see that we needed some kind of orchestration and some kind of interface there, right? And exactly why the way that I would see that be implemented on just with AIS components would be replacing both the items that are required to be extended on the sender, on the receiver, as an API backed by a logic app. So the logic apps in those cases would have all the logic to connect to the data repository, generate unique identifiers, and either insert the files into, or the messages into the data repository, or take the message out of that repository. While the API management would give you like a service interface, an API that I can easily call that from a sender or from a receiver, right? So now my sender doesn't need to implement code. I just have an endpoint that it can call, and my receiver doesn't have to implement that code as well. I have something that is reusable by those two components. And in this case, you can implement that both on Service Bus and event grids, because they are totally independent from the message engine. But the reason why I put Service Bus and event grid there is because you needed to understand on that case the limitations or why you're doing that. For example, those sizes that I was discussing, you have different sizes on Service Bus and you have different sizes on event grid for the message that it can support. Last one before we can go to some demos is the Sequential Convoy. So far, we actually processing the messages as they are generated by the sender. But what happens if I have like a fleet of messages and those messages actually have some correlation, and the receiver on the other side needs to process those messages in a specific order that is not the order that it arrives on the message engine. For example, in this case, I need to process A1, A2, and A3 in order, then B1, B2, and B3. But when they fly to the engine, they come in a different format, right, or in a different order. For that to work, I need somehow a way to identify on the message engine that those messages are correlated, so they can be pushed out or can be requested in a specific order by the receiver. And the receiver needs to know what is the unique identifier that I'm using, or some kind of correlation or ID that I'm using to pick up that, right? But once those two things are in place, both on the engine and on the receiver, then I should be able to pick up the messages in the right order. How do you implement that on AIS? Part of that comes out of the box, just requires some configuration, right? You can have queues and topics with a specific property called session. So if you enable session on the queues and topics, what you're doing is messages that share that session are going to be having that special component that identify that they needed to be processed in order. And on the receiver side, you need some code that says, I'm requesting session A, now give me all the messages related to that session. I finished that, give me the next session, right? And this is where logic apps can help you. On that particular case, this is so much such a common pattern, and people use that since the beginning, and you can see that being implemented multiple times on BizTalk, that you have a sequential convoy template ready on logic apps for you to understand how that's implemented and then extend for your own use cases. Now that we went through those three items, or those 4 items, let's see what we can do in terms of implementing that, right? What I'm planning to do is show you the claim check pattern example, right? And go through that and show how I implemented that, because this one is the one that has most of the code, and one that I see being reused multiple times in various projects. And if we have time, we can also go through the messaging filter for service bus and event grids and take a quick look at sequential convoy, right? But we're already going through 20 minutes out of 30. So let's do the demo, and after that we come back. Okay. So in this case, what we're seeing here is the implementation of the claim check pattern that we discussed with an API management endpoint, a logic apps that allow you to send the message into a repository. In this case, I make it really simple. The repository that I'm using is just a storage, and the same API management endpoint with a different operation, getting the receive, right? Instead of writing code or having a third party, I have a logic apps that simulates a sender and a logic apps that simulates a receiver. And you have the service bus in the middle. So let's take a quick look at what the sender is doing. So, as I said, there is Twitter involved, right? So when I receive a new message on my account that has integrated 2020, I creating the message that the claim check service requests, right? The format that the claim check service request. Then I posting that message on this API, and the result that I receive from that API, I'm pushing into event grid. Sorry, into service bus, right? I could be sending that to event grid. I just use a service bus because then it gives us the ability to explore some other things there. What is this claim check services doing is actually connecting behind the scenes into that logic app, right? So I'm not going to explore the API management right now. Let's take a look at what this one is doing. So what it does is basically I initialize a unique ID. I write that message into the blob storage into a specific location, and I send the message back, right? Which is the message that goes to service bus. If it fails, then I just send a 500 back. On the other side, the receiver when a message is received, first it goes, validates if the message is a valid message for what I'm expecting. Then it calls the claim check service to get a message of that type and that item ID. And receiving that, I'm assuming process for the just for the sake of the execution for that, and I complete the message. If anything goes wrong, then we can just abandon the message. Okay. Just for completeness, just take a quick look at the API. And the API that we have here is a claim check API with a post operation that basically, when that happens, it just writes into API management, right? And a get operation that when that's being called, it does a little bit of things. First, it changes from get to post. Then it generates gets the path and converts into a body that the logic apps would be expecting. And then calls the backend, right? So just to show how much the API management can help us to actually create a proper API out of a set of components that doesn't necessarily have the same contract that I would be expecting. So since the proof is in the pudding, what we're going to do now is please demo gods, I never asked you much. Integrate 2020. Let's tweet that and go back to the client sender. Right, the last one was 4 a.m. So I'll try to run the trigger again and see what happens. We have one running at 6:43 a.m. And it completed successfully, right? So that means that it calls the claim check service and it sends the message to service bus. If you go now to the receiver, 6:43 a.m., it already picked up the message. And what it did is it tried to validate, the validation was okay. It calls the claim service, the claim check service, receive the original tweet message back, and completed the message on the queue. For completeness, what the claim check sender did, as we saw, was initialize that variable, create a blob called tweet message with that 5e finish on AD, and return back the response. His counterpart simply went to the blog on that path and pick up the content back, right? So that was the this demo. Since we're running like it's 28 minutes now, and I still wanted to give you some summary of what I want you guys to take away from that. I'm not going to go through the other items in the menu for the demo, but most of those are actually things that you can find out of the box anyway on the portal, right? So if we come back to the presentation, from a summary point of view, what I would like you to take out of this session is AIS is going to support pretty much all the integration patterns that you are used to, right? We talked about claim check patterns, we talked about publish subscriber, we talk about the sequential convoy, but I could be talking about batching and debatching, message enrichment, and all of that has a way to be implemented inside AIS. Understand what is the messaging service that that you want to use and what is the messaging service provides. So first, you don't reinvent the wheel, right? Since the message service bus provides the sessions there, you don't have to find another way to do that. But on the other hand, you know that it doesn't provide a claim check, so you needed to implement this. And also understand that, again, messages versus events, what is the type of service that you want to use for a specific work. And finally, remember that other services like Logic Apps and API management that is inside the AIS umbrella is going to help you to compose some of those reusable patterns. So for example, the way that I implemented that service, now I could reuse that for any component that requires a claim check pattern inside my ecosystem, right? So you could start to do the same. You can start to create your reusable components and just plug in on your orchestrations or on your workflows. And with that, this is what I wanted to show today, right? Thank you for joining. If you wanted to get in touch with me, you can go to Twitter on WSilveiranZ, or you can send me an email on wagner.silveira@note2self.tech. And I usually blog about pattern samples and things that I see when I'm working that I think it might be interested. So if you wanted, you can either subscribe or take a look at my post, my blog, note2self.tech. Lex, how are we going with time?
Yeah, we only have 2 minutes left.
Okay.
That's already the extended time. There are a couple of questions in the Q&A. Do you have them at hand? Exactly. How can you guarantee at least once execution if Service Bus doesn't have endpoint supporting distributed transactions?
Yeah. So I was looking at some of the questions, and just let me see. You say, how can you guarantee at least once execution if Service Bus doesn't have endpoint supporting distributed transactions? So the way that we're dealing with at least once is using the pick and lock mechanism that we had that I showed, right? So guarantees that all the message is received but also processed before you commit it back, and together with the dead letter queue.
Yeah, no.
When the next one for John is when subscription filter access via the Azure portal will become available. Is available right now, right? So maybe just be able to show that one quickly. You guys still seeing my screen?
Yeah, we have your screen.
Okay, so I'll find there we go. So here I have a topic. We face with some subscriptions. And on that subscription now, you should be able to see the filters and either add a filter or see the existing filters. Tom put some notes here from reliability. So user message broker that implements high availability for critical transactions. Many cloud applications use message to trigger asynchronous tasks. So to guarantee delivery of message, the message system should provide high availability. Azure Service Bus message implement at least once semantics, which means that the message is guaranteed to be delivered at least once. Duplicated message would be responsibility of the client. And he's just showing here some examples that we can get from the architecture. I'll make sure that I'll put that link on Twitter so people can use that as well. Yeah. Retries with Azure Service Bus Topic and subscription. As I said, the subscription becomes a virtual queue. So the client is going to be coming to the queue, pick up the file. If he's not able to process that, the message if you're using the pick lock method, is going to be back on the queue, and you can try that again. Leaf just showed that just confirmed what we just said, that the filters are now available in the portal. And how do you implement batching of related messages across multiple subscribers without having to create a new receiver for each subscription every time that we add a new receiver? Just let me see if I can understand that. Maybe I'll get that message, that question from Mahish, and I'll get in touch with him, because we're running out of time and I have to understand that one properly.
Yeah, indeed. There are a couple of more questions on the pending as well, but maybe indeed you can just take them offline. So then we can wrap up the session for now. Okay, yeah, well, Wagner, thanks a lot for, you as well, being with us again. Well,
thank you guys. Thank everyone.
It was pretty tough for you to follow the conference, but still indeed good that you're there. And to the audience, this was the last session for today. And tomorrow we will be back at noon UK time, of course, with a session of Matthias Luckberg about improving your APIs with RBAC security. So we are all hoping to meet you again tomorrow, and we hope you have a good rest of the day. Thanks, everybody.
Thank you. Thank you, everyone. Have a good night or good morning in my case.
Yes, indeed.
Covey.co